Today, I'm going to share two versions of a video upscaling workflow with you, both based on LTX Two. Since we know LTX Two has both generation and upscaling capabilities, I've been wondering, can it be used to upscale our existing videos? So I did some experiments, and the final result is exactly what you see here. We got a really nice high definition upscaled video. Of course, there are some details to cover. First, we have two versions, a simplified one and an advanced one. Also, during the upscaling process, there are some specific issues you need to watch out for. How were these workflows derived? What explorations did I do? And what potential problems should we pay attention to? We'll explain these one by one. I've also built these workflows on Running Hub, so you can access the platform directly through there. In the ComfyUI field, Running Hub is a fantastic online workspace because as soon as new models or extensions appear, they update immediately. You can register using the invitation link in my video description to get 1,000 free credits. Plus, logging in daily gives you another 100 free credits, so you can try out your own workflows completely for free. The inspiration for the first version of the workflow comes entirely from the LTX image to video workflow. I removed the basic sampling part and kept only the upscaling section. First, we have a video input here. I forced the frame rate to 25 FPS. You can restrict this or not, but the reason I did this is that the LTX Two model handles audio, and in almost all model-based audio processing, the recommended video frame rate is generally 25 FPS. It's the same for LTX here. I extracted 121 frames from the video since the original clip might be too long. Next involves loading the main model. I switched this to use Kijai's nodes because the native ComfyUI nodes have too many complex associations between models. Making it look messy, Kijai has optimized the model organizational structure. Let's look at the parts. First, the main model. There are many options now. We use the transformer model, loading it with the load diffusion model node. Then there is the quantized model. If you want to use it, give it a try. Theoretically, the Q8 quantized model should perform better than FP8. Kijai also separated the VAA part completely, having both audio and video VAEs. Plus, inside the text encoder, there's a new addition called the Embedding Connector. Using this, we can use a dual encoder loader node to load our text encoders. Let's look at a specific example of the setup. First, I used load diffusion model to load Kijai's main model. Here's the video encoder and the audio encoder, but we are using Kijai's VAE loader node. Then comes the text encoder using the standard dual encoder loader. We have two models here, the traditional LTX text encoder model, and then we loaded the embedding connector provided by Kijai. You'll notice the model loading becomes much clearer and more organized this way. The subsequent steps are pretty standard. We need to process the video since we are upscaling. I resized it to 1280 x 720. Then I scaled it down to half its size because later we will use a latent upscale model to bring it back to the original resolution. So we shrink it by half first, then encode it to get the latent data. This encoded latent data is then concatenated with our traditional positive and negative conditions to form new positive and negative conditions along with our latent. For the prompt, I kept it very simple. Since we are just upscaling, I uniformly wrote best quality of a beautiful girl. Since the whole workflow comes from LTX Two image to video, we take the first image of the video and use it as the guidance frame. We use the same method first to resize its long edge to 1536, then compress it. This gives us a first frame image. Later, we use a node to inject this first frame condition into our latent. The key point here is, where does this latent come from? First, we VAE encode the original video to get a new latent. Then, we spatially upscale this latent to the resolution we need. Next, we use this node to add our first frame as a condition into our upscaled latent. This becomes the final latent we use for sampling. The tricky part here is actually the audio. This audio comes from the original video, but if you don't have an audio input here, the workflow won't run. So I used a workaround. First, we generate an empty latent, use it as input here, and connect it with the original video's latent to get the latent needed for sampling. Then we perform the upscaling sampling. Here's the seed. Since we loaded an acceleration LoRa, the CFG is set to 1.0. How many steps? 4 steps. Since we have a manual sigma with 4 values here, you can guess it uses 4 steps. For the sampler selection, there are many options, but we suggest keeping it consistent with the original image to video setup. After sampling, we use a node to separate the video and audio latents. We only need the video here because the audio was just an auxiliary element generated to facilitate the sampling. Then I connect the original audio back in. That covers this part of the workflow. Let's look at the result. Here is the original video and here is the upscaled video. It's obvious the upscaling effect is fantastic. Visually, the result looks good. However, if you look at the generation mechanism, there is room for improvement. The issue lies right here. When we use the first frame as the guidance image, we are using the actual first frame of the video. We know videos consist of keyframes and interstitial frames. Keyframes are usually clear, but interstitial frames are sometimes clear and sometimes not. So if you pick the first frame, you can't guarantee its quality is sufficient. Therefore, we can use some basic processing techniques, taking a high quality guidance image to replace that first frame. Now, let's look at the second workflow. In this version, I uploaded a separate image here. This image is a high quality processed first frame. I scaled it to 1280 × 720. Take a look at the final generated result. There's a clear improvement because we strengthened the guidance of the first frame. Some might think, is the first frame guidance actually a fake concept? No, it is not. Let me show you an experiment. Notice that at this node, we added the guidance image as a condition. There's an option here called bypass. If we set this to true, it means this node won't function. Let's run the workflow again. Look at the video, you get notice that the character consistency is completely lost. Also, the movements and other aspects of the scene have problems. This experiment proves that the quality of the guidance image directly affects the quality of your upscale. Of course, this raises a question. Where does this better image come from? You can use various methods. For example, you can use a model like Nano Banana to restore the first frame, or use Qwen Image to restore it. Both work. Here, I used Qwen Image Edit Plus. Let's look at the restoration workflow here. We have the Qwen Image Edit plus 2511 main model, added an acceleration LoRa, and then chained an upscaling LoRa after it. This is the first frame of the video. Look, it is actually unclear after resizing and processing. We get a much clearer image. Note that consistency might be slightly damaged, but overall, the benefits outweigh the downsides. When using this model, pay attention to the trigger word. You can check the LoRa page on Hugging Face for details. Usually we set the weight to 1.0 and the prompt is what you see here, asking to upscale the image to 4K. That is the upscaling workflow. You can also use other upscaling methods if you prefer. To verify the results, I did a lot of testing. Let's look at this one. The advantage here is that I already had a high definition version of this image. The HD upscaling effect is very obvious. Now let's look at this test. Through this test, I want to highlight the problems with this upscaling method. First, realize it is a sampling upscale. So the final result might not align perfectly with the original video. For example, look at the girl's appearance. It actually changed slightly. Also, look here. These were originally text stickers, but here they were interpreted as something else. Let's look at this final example. The upscaling effect is obvious, but because processing the first frame might change the character's facial features, you'll find the character is about 80% similar. In this video, we first verified that using the LTX -2 upscaling workflow to directly upscale an existing video is feasible. We also provided two different solutions. Depending on your scenario, you can use the simplified version where you take the video's first frame directly as the reference, or use the second method, process the first frame with upscaling and restoration, then use it as the reference frame. This will yield better results. So what are you waiting for? Go ahead and try it yourself. Subscribe to me to become someone who truly understands AI.